Today, I will introduce our paper, Addressing Correlated Latent Exogenous Variables in Debiased Recommender Systems. Recommender systems face a challenge in unbiased learning due to selection bias. Despite the progress, previous debiased method assumed the independence of the exogenous variables. In these papers, we release these assumptions and consider the bias caused by correlated exogenous variables in a parametric models, and propose a method that can achieve unbiasedness. For our contributions, we first define the data generation process. We introduce two correlated latent exogenous variables to measure the randomness in observation indicator and outcome under a normalities assumptions. And given this, we model the latent observational behavior and real preference and induce their joint Gaussian distribution. The likelihood objective can be also formulated as follows. And second, for continuous user preference, the marginal distributions of continuous user preference is a standard normal distribution. So it's easy to show the density functions, and the full log likelihood can be used to estimate the parameters. Also, for more common scenarios like binary user preference, since computing the log likelihood for such a case will involve integrating over both observational behaviors and real preference, which lacks a closed form solution. To handle this, we use Monte-Carlo's estimation to approximate the intractable likelihood and utilize the symmetries of the joint distributions to decompose the optimizations into two sequential subproblems and optimize these two goals iteratively. Our method can outperform baseline under large latent correlations and recover the true correlations from interaction data. That's all the things. Thank you so much.